the acceleration, and we did the explore activities, we did the twig, secondary, and now we're gonna see how we're gonna describe the motion if we are given graphs, whether it's position versus time graph or velocity versus time graph. So your title is gonna be describing motion with graphs. And we talked about in physics, when we want to prove something, we always have to do CER, which is your claim, your evidence, and your reasoning. We did this the first week of, probably the second week of school. If you need to review them, you can go to week 2 on the WAG and check what we mean with each one of them. All right, so what do we mean when we say graph? So sometimes you will be given a graph. So this is going to be example 6. Okay, and you have this graph. That is your time in seconds, and you get here position in meters. And I'm just going to form a straight line, and you're going to just, this is, let's see here, 10. This one right here, 20, 30, and here I got the time 1, 2, 3, 4, and this is 4. So what's happening here? So when we look at it, we see that there is motion. There is motion because this is moving, and the distance is getting bigger. So we know that there is motion. So your claim would be there is motion. That is your claim. What is your evidence? I can say my evidence is that the distance is getting bigger. Distance increasing as the time increases. Evidence and reasoning are pretty much the same. So you're going to say, how you're going to do your reasoning. You're going to look. So you said it's increasing, right? So because you said it's increasing, I want the reasoning. How do you know it's increasing? So you would tell me that the graph started at 0. So the graph starting point was 0 meters and 0 seconds. It's right here. After 1 second, the distance traveled was 10 meters. 2 seconds later, distance traveled 20 meters. And then you can say 3 seconds later, distance traveled 30 meters, and so on. So that tells me now I have my claim, my evidence, and my reasoning. And now I know that the object is moving rightwards, or not rightwards, I should say, rightward or at constant speed. How do I prove that this was at a constant speed? So I have position and I have time, and I know this is a straight line. So the slope is the position over the time. Slope is distance 2 minus distance 1 over time 2 minus time 1. And I know that this is the formula for velocity. So the slope is equal to velocity. As I said, you pick the easiest point, which is 0. You can pick any 2 points, but I'm going to pick this, 0, 0, and 110. So it will be 10 over 1. Velocity is 10 meter per second. And remember, you have to write the unit. All right? So here it's very important that you write this is a constant velocity. So when you look at the graph, you know it is a constant velocity. What else? Is it enough to say constant? So this right here, I can say this is positive because it's going up and constant velocity. And we actually proved that it's positive when we found the slope. So that will give you positive and constant velocity. Okay, I'm gonna do a few more examples. So that was example 6. So let's do example 7. You have time in seconds, and you have position in meter. And you have this graph here. So what's happening here? It started off kind of like a straight line, right? So we can say started at 0, 0, right here. We can say took off at a constant speed. So that motion was started with a constant speed or a constant velocity. And then there was change then changing velocity, and that changing velocity gave me acceleration. And it's all going into positive. All right, let's do example 8. So you have a graph and you have two different cars. So this is time in seconds, and this is position in meter. So you have two graphs. I'm going to do one in red. Let's do, this is the first. I'm going to call it car 1. And I'm going to name this car 2. Okay, what is happening here? So this is again a graph of time versus position. So when you look at this, what do you see? You see two cars. One of them is steeper than the other. Which one is steeper? Car 2. So it seems like car 2 is steeper than car 1. It seems like car 2 started at the origin, or let's say at 0, 0. Car 1 started at 0, 0 as well. And then car 2 seems to be closer to the y-axis. So car 2 is closer to the distance. What does that tell me? Now the thing is that car 1 and car 2 are moving at a constant speed. At a constant velocity. Okay, that tells me that car 2 is faster. In conclusion, car 2 is faster than car 1. Both are moving right forward. Rightward, which is positive. Okay, this is kind of how we analyze the graphs. Okay, so we're going to do another example. That would be example 9. example 9, I have two objects moving, and I got the time and the distance. So again, I'm going to do car 1 and car 2. So this would be car 1, and this is going to be car 2. So what's happening in the two cars here? So I don't know if you guessed it right, but yes, one of them is moving slower than the other. So your claim would be, let me do this. Claim is that I would say car 2 is faster than car 1. Now, what is your evidence? I'm sorry, what is evidence? It's because when you look at it, car 2 is steeper than car 1. Well, what is your reasoning? Your reasoning is because car 2 reached the final destination in less time. So as you see here, this one, if it keep going, the time is going to be bigger. So the more time you spend, that means the less speed you're going. And one interesting thing about it, the car 1 and car 2 has a constant negative velocity. Okay, they both have negative velocity, but one of them is larger than the other, which is car 2. Okay, so what we're doing pretty much is just we're looking at the graph, trying to get the data, trying to see. So the slope in both graphs, slope in car 1 and car 2 will give distance over time, which is your velocity. Okay? All right. Let's see if we need to have another example. Let's do one more. So, let's see, what, 9? Yeah, 10. All right. Example 10. What do we have for example 10? We have time in seconds versus position in meter. And I'm going to label this 1, 2, 3, 4. This is your time. And I'm going to do here by 5, 10, 15, 20, 25. And just going to do 1 and 5. So I'll probably do it this way. All right, so what is happening here? I have time and position. So your claim would be, what are you claiming? I claim that the object had a constant velocity, then stopped moving. So what is my evidence? My evidence, if I look at the graph, I have distance increasing as the time increasing up until t equal 4 seconds. When time was 4 seconds, the object had same distance, which means didn't move. How do I explain this? What is my reasoning? So for your reasoning, you would say for the first, of course, you're going to word it the way you feel is more understanding to you in your own words. You don't have to do the same words I'm using. But they have to make the same concept, of course. For the first 5 seconds, or no, 4 seconds, I'm sorry. For the first 4 seconds, what happened from here to there? So if you look, 4 seconds. The line on the graph so let's see. The slope, since I have a straight line that is increasing, I got the slope, which is, I'm going to pick any 2 points. Just going to do probably 0 and 0 and 5 and 1. So your slope will be 0 minus 5 over 0 minus 1, or 5 minus 0 over 1 minus 0, which would be 5. and this will give you your slope or your speed. All right, so, or velocity, I should say. For the first 4 seconds, the line on the graph slopes up or speeds into 5 meters, right? Then the first 5, and then what happened? And then this would be your velocity, right? And then when the time was 4 seconds, the line didn't change in position. So when you don't change in position, that means there is no motion. That means you're not moving. Okay? So in other words, the velocity after 4 seconds was equal to 0 meter per second. Because the object is not moving, right? It was just standing still. And how do we know that? It's because of the distance that is not moving. It was 25 meters all the way. All right. So let's do another example on, but this I'm not going to do a CAR. I'm just going to show you slope, just example on the slope. That would be example number 11. So for example 11, you have a time versus position graph. That's your time. That is your position. That's meters. And that's seconds. Now I got and then here I got 10, 20, and 30. Okay, so what I'm gonna do, I got, let's see. Now 9 to 6. So this point here would be 0, 26. And this one here would be, I'm going to take that one. Would be 4 and 10. Okay? So what the first thing you think of when you look at this graph is that I will have that this is not probably, that there is the motion, slow down in the motion, So this is slowing down, which means I will have a negative slope, which means I will have a negative velocity. So if you're finding the velocity and your velocity is positive, you should automatically know that this is wrong because this one is going down, it's decreasing. Okay, so how do we find velocity? Velocity is your slope, which is pick any 2 points, any 2 points. Okay, so we're gonna say it's, all right, let's do that. Velocity would be, let's choose whatever we have given, even though you can choose really any. So I'm gonna do x1, y1, x2, y2. So you can do 26 minus 10 over 0 minus 4, which is 16 over negative 4. 16 over negative 4, that would give you negative 4 meter per second. Remember, this is meter second, which should give you meter per second. So since I know that this is negative 4 meters per second, I know the negative sign indicates a drop. Okay, so you know that there is a drop in here. All right, this would be it. We're gonna do more meaning of shapes and graphs, but this is it for now for this video.